Assalamu alaikum everyone, hope you're all fine. Welcome back to my channel. Today I'm making the video on computer science 9618 paper 2, and my today's video's topic is linked list, which is an important part of the ADT. So let's start. Linked list, let's talk about its main features. So the elements of the linked list, they are not adjacent to each other the way they are here in the array. You can see the elements in the array, they are adjacent to each other, but the linked list has the elements scattered on various different locations. So the linked list are dynamic in nature, so we can change the size, and we only have a new elements when we need it. All right, the elements in the linked list, they are called node. So these are nodes. Based on the need to store data, we can request more locations in the linked list. Based on the need to store data, we can request more and more locations. So that is why it is dynamic in nature. All the nodes in the linked list, they are scattered over the memory. So as I said in the start, that they are not consecutive and they are not adjacent to each other, the elements, the nodes. In arrays, we have consecutive indexes, like I told you here, that we have indexes 0, 1, 2, 3, 4, 5. So they are adjacent to each other. While in the linked list, we have to keep record of the next node using pointers that tells the location of the next node. So this is the node and this is the pointer. So the pointer is telling us the location of the next node. All right. Now the key terms. The key terms associated with the linked list, they are node, pointer, null pointer. So node, what is node? Node is an element of the linked list, and pointer, a variable that shows the address of the next node. So actually this is how the linked list is different from the other data structure. So every element is having the data and then a pointer that points, that tells the address of the next location of the other node containing the data. Then the pointers normally used in the linked list, there are some pointers like the null pointer, which is very important. Null pointer is sometimes designed as like, it can be designed like this in the shapes. It is this, or it can be 0, or it can be -1. So null pointer can be in any of these shapes. So null pointer is a pointer that does not point to any node. So it is actually the end of the linked list. And the start pointer, it is actually a variable that stores the address of the first element of the linked list. So we can say that the start pointer point to the head of the linked list and the null pointer point to the tail of the linked list. Okay. Now this diagram tells all this that we have just discussed. The start pointer is this, you can see, is pointing to the first node, and this node has B, and then this B is the data, and then it has the pointer that points to the next location where the other data is stored, and that is D. So then this D, this is the data, and then there is an address which is a pointer to the another node, which is L, and then that node has a null pointer that shows that this linked list is ending here. All right. Then there are certain rules that you must follow while working with the linked list. And what are these rules? The rule number 1, all the elements, node, data should be inserted in the order. So if we have B, if we have D, if we have L, and if, so you see that the B, D, and L, they are in the order. If anything new will come, like A, so A will come before B, D, and L. So this is the, this is an important thing. So linked list is, that's why, an ordered list. All right. So linked list is one way, it is a one way in reading and processing. We cannot go back, we can only go forward with the pointer. Number of the nodes in a linked list initially is unknown. All right, that is why we call it as a dynamic data structure. All right, after that, in the linked list, we have another very important concept, and that is the free list. And what is that free list? Basically, it is an equivalent list available with the linked list. So whenever a node is deleted, it will be given at the start of the free list. And whenever a new node is inserted, added to the linked list, it will be taken from the start of the free list. So either we are deleting or we are adding, we are giving back to the free list, or we are borrowing from the free list. So this is important. So the free list is actually picking the next available node from the linked list always whenever a new node is inserted. All right. Now let's start the processing of the linked list, and the main processing is the addition and the deletion which is the adding a node, and which is delete a node. So these two operations we need to carry, and in order to see that how the linked list they work. Now let's see, this is an initial form of a linked list. We have a start pointer which is pointing right now to the node which has B, and then we have D, and then is L. So you can see that these are the elements and these are the data in this linked list, B, D, and L, and they are in the right order. Start pointer is pointing to B, B is pointing to D, and D is pointing to L, and L is pointing to nothing. All right. Now we want to add A, for example, in it. And now this is addition at the start. We will add A. So we first create a node A, and then we will look at its right position. And as we said that the addition A will be done in the start, because as per the sequence, A must come before B. So carefully monitor and observe that which steps we will follow in order to insert this A, as it is before B. So what first step we need to do is that the pointer, start pointer which is pointing to B, will be removed. All right. And this start pointer will now point to A. And then A, which is smaller than B in the order, now A need to point to B. All right. This is how A is inserted at the start. All right. Although you should note, there is a note here that what is this note? Note is that this is the conceptual diagram. All right. This is the conceptual diagram of the linked list. So you have seen, what is this? This is adding the node in the beginning. So add node in the start. All right. This is how we've done it. We added the node in the start. All right. Now the next is that add the node in the end. The next point is add the node in the end. That node is M. All right. So we have to first create the node. And now again we have to see that what is the order. M comes after the L. So what steps we will follow? We'll first remove the null pointer of the L, and then L will point to M, and then M is going to point nothing. So it means the null will be inserted here. Okay. So now this is adding node in the end. This is how we added the node in the end. I'm sure it is clear. Now these two things we did with the one is adding and one is removing. Now we also can see that adding the node in between. The third thing is that add the node. This is the third thing. Add the node in between, number 3. In between means somewhere in between, depend on its right. Now what we are doing, we are adding the node in between. For example, that node is, let's say it is C. Now we have to start from the beginning, and from the beginning we start and go to B, and B is less than C. Okay, then we go to D. D is greater than the C. So actually the right position is in between B and D. So what we'll do now, again the same steps. We'll remove the address, the pointer from B to D, and then this pointer will be pointing to C, and then C is going to point D. This is how the node is added. Node added in between. So the node is added in between in its right place, in its right position. All right. Now let's do. This is all the addition. So we have added. So this is addition. Now is the removal. Now we are going to remove the nodes. How will we do that? delete node. So deleting the node, again, it can be from the start, it can be from anywhere. All right. It can be the first element, it can be the last element. So how will we do that? Deleting the node, let's say we want to delete B, which is in the start. How will we delete it? The rule is that the start pointer which is pointing to B is going to point, the start pointer will point to D. And this is how the B is removed. This is how the B is removed. Just by changing the pointer, the start pointer, which was pointing originally to B, will not point to B. It will point to where it was pointing. It was pointing to B, and then B was pointing to D. So that connection is deleted, and now start pointer is pointing to D. So this is how we removed. So we deleted from the start. All right, we deleted from the start. This is how we deleted from the start. And now if we want to delete from the end, how will we delete that? Again, the same procedure we will repeat. The D which is pointing to L, is that connection will be broken, and D is not going to point to L. D will be rather in this form. So this is how the L is deleted. This L is deleted, and in this case you have seen that this B was deleted. So this is the deletion from the, we delete from the end. So this is how the node is deleted from the end. Okay. And if you want to delete from any position, you just need to see the previous pointer, and then instead of pointing it to that node which you want to delete, that previous pointer is going to point to the pointer which that node's pointer is addressing. All right. So basically, this is how the addition and deletion is done. Now coming to the important part, and that is using, now we are going to do this with the help of the free list. All right. Now we'll do the same, but with the help of the free list. As I told you that the free list, what is the free list? You remember in the beginning, I told you that the free list is the list available in computer memory whenever required. Whenever required. All right, so free list is available in the memory. So this is the list available in the computer memory whenever required. And when we acquire a node, so basically when we acquire a node, we take it from free list. All right, and when we delete, we give it to free list. This is what I explained it in the beginning of the video. All right, now let's do the same thing again with the concept of the free list. So all right, now you can see that with the start pointer, with this is the linked list, this is our linked list, and with this linked list we have an equivalent free list available to us. So this is the free list, and free lists node, they're all empty, and nothing is in them. Now when we want to, we will do this now in order to explain it. So you see, for example, we want to add a, now by using the concept of the free list, when we are going to add a, we will first use it from the free list, the free list pointer, which is pointing to this node right now. Free list is pointing to this node. So we take this node, we prepare a here, and then the free list pointer is now will not point to a. Now free list will update, and it will then point to the next available node. So this is first thing that the free list will do. After giving the node to be used by the linked list, the free list will point to the next node. All right. Now that node is available for the free list linked list. And again, we will repeat the same process for adding the value in the beginning. Now this start pointer will point to A, and A is going to point B. All right. This is how the free list is used to add the node into the linked list. All right. This is how we added the value into the linked list. Now, if you want to, this is an addition, and if you want to remove something, let's do the same. So this is adding a value. What we did here, it is adding add node using free list. So you have seen that how we added a node using the free list. All right. Now when we remove a node, where will that node go? We want to, what we're doing here, we delete node from end. So actually we want to remove L. So what we will do here, as you have learned, that first of all, the D will not point to L. So D will mention the null pointer. So then the L free list is going to point to, as I said, that whenever value node is removed, it will be added in the beginning of the linked list, the free list. So this is how a node is given back to the free list. All right. So you can see that the list is ended here, the linked list, and this node got free. So what we did, the free list pointer, which was originally pointing to this node, will change its pointer, and it will point to the node which is recently deleted. And then that node which is deleted, now it becomes the first node of the free list. This is how the value is removed from the linked list using the free list, the concept of the free list. All right. Now we can also move on to the next very important part, and we can also show this on the values we just added here. Let's say these can be given the numbers, they can be given the labels, how the free list they will be. Now it's implementation of the linked list. Let's understand it more clearly. So implementation of the linked list using the arrays, and how will we do that? How can we show this? This will give you a more better understanding of the. All right. So this is the diagram of the linked list in the array form, and this is 1D array, and it has data and pointer, and how this data and pointer will be created. One part is the string, and the other is the integer. This is done with the help of the record type, and you already know about using the record type. So when the linked list is created, for example, an empty linked list, the start pointer now in this case will be pointing to -1. Start pointer will point to nothing, and the free list pointer will point to 0 when the linked list is empty. All right. And as it is the free list, so all the nodes, they will be pointing to the next indexes. So this is the first node. So free list is now pointing to the first node. So first node will point to the next node. So this is the next, this is the next, this is the next, and this is the next. And what will come in the last node? It will point to nothing. So it will be -1. This is when the linked list is created, when the linked list is empty. All right. Now, when we will enter the values in it, right, when we add, now we are going to start with the working. And for example, we want to add the values that we have used here, which is B, D, and L. These are the values. We have B, D, and L. So let's insert all of them here. So how will we insert them? So if we have B, D, and L here, so we just need to update the pointers. Now the free list pointer is not going to point to 0. Now in this case, the free list pointer is going to point to 3 because its job is to only point to the next available node in the linked list. And where the start pointer will point now, the start pointer is going to point the head, which is now 2. So basically start pointer will point here. So this is from where the linked list is starting. And now B, you can see that the B is pointing to D. So we need also to update its pointer. B, which is right now here is 3, we'll remove this 3. And now B is pointing to D and its index is 1. And D is pointing to L. Now its index also need to be updated. So how will we update? Now D is pointing to 0 and L is pointing to nowhere. So L will be -1. So this is, you can see, the implementation of, we can say that this one here, the initial part, an empty linked list. So this one is implemented. Now start pointer is pointing to B, B is pointing to D, and D is pointing to L, and L is pointing to nowhere. So this is how the free list is implemented in the form of the array. Now with the same, let's move next and we want to add a value in it. All right, we want to add A. So we'll do the same with this diagram now. Okay, now we want to add A. So where will we put A? We'll put A where the free list pointer is pointing. Okay, so in the last, I have not changed it. It was pointing to 3. Right. Now where the free list pointer is pointing to 3, so the A will be added here in the next available space. And free list pointer is going to update its pointer. And now after giving this node for the free list, for the linked list, free list pointer will update to 4. All right. And now the start pointer, as you can see that the A is, now we need to see that where to connect the A. A is in order less than B. So the start pointer, we only need to change the start pointer as you did in the conceptual diagram, that we only change the start pointer. So the start pointer, instead of pointing to B, will now point to 3, which has A. And this also need to be updated over here. All right. Now where should A connect? A now need to be pointing to 2 because B is at index 2. So this is how we inserted. We added a value into the linked list. Okay. Now, for example, we want to remove L. So you can see, you can implement all the things. You can remove any point from here. You can add the values. If you want to remove L, what will happen? The L pointer, you can see that L is pointed by D. So the D will be done -1. And instead of pointing to L, it will be -1. And the free list pointer will now point to the, instead of pointing to 4, the free list pointer will point to 0 in this case. So it can jump on various locations. All right. So it doesn't matter that where the sequence is. It can go back on any other index. So it will go to 0. So actually the free list pointer is now pointing to 0. This is the empty, and the L will be connected to the, not to -1. Now it will connect to 4. So it means the next index after the L. So wherever now any other thing that will come, it will replace L, which is pointed by the free list pointer. All right. So this is how we implement the concept of the linked list, and I explained it in detail. I hope it will help you a lot in understanding the process of adding the values, deleting the values. And in the past paper, full length questions, I will be doing the questions related to stack, queues, and linked list. All right, this is all for today. Thank you very much. Allah Hafiz.